Right, what a frigging job I've just had trying to get these previous drive coils out from in there. I'll tell you why, because I used some plastic glue stuff which I used in my course to, because remember I'd melted these before, so I had to basically melt them back together again with some glue. Well, what happened was it must have been bubbling up with the heat when I run it the second time round, because this freaking thing was stuck to the plastic inside. I couldn't get the damn things out, so I had to ram my steel ruler down the middle to break this free, because I just couldn't get it out and my frigging arm is killing me. And then I had to use my chisel to clean out the hole. I'll show you what I mean, what a mess it's made. See if I can get it on camera while it's clear. Right, let's see. Right, shine the torch up to the top. Let's see, can we get this on camera? Hang on, can't seem to get it. Let me just put the torch on this side again. Let me just go on the other side. It's a bit easier to see. But the top, oh, you can't really see. This is the drawer where my coils go. Now on the ceiling there's a dimple. You can see a little spot right in the middle there. Well, that's where it welded. You can see two spots actually. That's where the frigging thing welded itself from these two spots here to the freaking drawer, and I couldn't get the damn thing out. So what the frigging hell's wrong with it? I can't get it. Why can't I get it out? And I thought to myself, hang on a minute, has it gone and melted itself to the ceiling? I thought, well, how could that be? Anyway, I've taken the old coils out. These are the two drive coils, and you can see how badly get it to focus. Focus, come on, focus. Why is it not focusing? Anyway, you can see how melted it got. Look at the state of that around the ring. Yeah, terrible, really bad. I actually used some glue in the middle, so that's epoxy I used to try to repair it, and the coils got damaged because I was trying to get them out and I couldn't get them out. And look at that one. I repaired that one with some gluey stuff, and it's all bubbled up again because the wires were bare and showing on the sides. This is why I decided to replace this thing, because I had issues. Anyway, the new coil assembly is here, and I decided to use some thermal tape so it won't happen again. So I've got this thermal tape that runs all the way across the drive coils. This is my trigger coil. This is the trigger coils that sends the pulses back to tell the circuit, the MOSFET driver when to fire these three coils. Right, so I've got all the whole drawer assembly is ready to go in. I've got it wired up. This is these two wires. This is a trigger coil wire. I'm hoping I shouldn't get interference, but it should be fine, because the previous one, these previous coils were right next to the trigger coil and I had no problems. It was working fine, so there's no reason why it shouldn't work on this one. Oh, actually I can salvage my blue tack out of here now, because I'll be wondering where it's all gone. If I can get it out. Another reason I'm using a different wire, because this friggin' Chinese this telephone wire is magnetic, and it kept rattling about inside when the rotors were spinning. I'm trying to do this with one hand. It's kind of tricky. So I'm just trying to get this blue tack out of here. Come out, you bugger. Of course it got heated up, didn't it? So it will be really well stuck in there. Right. See if I can get the rest of it out. That telephone wire is not really good for mounting near magnets, because it rattles and vibrates with the flux and causes other problems. And well, I've got most of it out. I'll get the rest out later. So the new assembly is ready to go in. I'll show you how simple it is. I'll put this tape on the top and on the bottom so we won't have any more melting issues where it bonds itself to the drawer. Hopefully. So I'll bend these wires up a bit. I don't want to catch them or anything. I already hooked on my battery a bit ago. The drawer assembly with the drive coils just goes in this. Goes in. Oh, let's just rotate it around a bit. Goes in like this. I'm stuck now. Hang on. It's because something got warped. It's probably this tape's a bit thicker. It is a snug fit. Hang on, I'm trying to hold it with my finger. Now there we go. Right, there we go. It goes in. I'm in the light. There we go. It's a snug fit. So the whole coil assembly just slides straight in like that. You can see it on the other side. Well, you would if there was light on it. There it is. It comes out of this side. And all I have to do is wire it up and test it. Well, I'm not going to do it right this minute because I've only just bonded the draw everything together. I want it to dry properly because I'm worried it might go and stick in and not get it out again or something. So I'm just going to push it on the back to get it out because it is a snug fit. Just pull it all out. Easy to maintain. That's the idea. The idea is I'll be able to make changes and improvements to it and just slide the whole lot out in one go. But things don't always work the way you plan, which is what happened to my old ones, which friggin' melted on me. Well, I was overdriving it, to be honest. It turned out that the magnets that were in there, which are not on there, they're on the concentrics, which aren't on here now because I've taken them off. But the magnets previously got destroyed by the heat. Well, I was overdriving it. I was trying to figure out what was going on with it, and I turned the voltage up to like 30 volts. 30 volts, and it was about half an amp. I'm thinking, what the hell's wrong with it? Why is there no power? It was working great, and then it stopped working properly, and it turned out I'd cooked my magnets. Yeah, so anyway, these new ones, the magnets are actually mounted further away, and they've also got the steel laminations that run around the back, which add to the magnetic coupling, and also they'll also keep the magnets cool. So they'll actually heat sink the magnets, so the magnets shouldn't get cooked like they did last time. Yeah, so we'll see how that goes. It's going to be a lot of fun when I get this all hooked up, because they're all wired up in there. They're in series alternately, because obviously the poles change, so it's basically the drum is probably a north pole there and a south pole here and a north pole here, so I've had to alternate. This one's, they're all in series, but the one in the middle is wired inversely so that it will still push when the others are pushing, so they're all pushed together every half wave cycle. So yeah, anyway, the reason why I don't want to put it in the drawer yet is because it's still drying, and if I don't let it dry evenly, it'll warp. I don't know if you can see this, but there is a slight bend in it. So what I'm going to do is I'm going to leave it upside down, and I'm going to go to bed. Not yet. I'm going to go to bed in a bit. I'm going to let this dry out overnight so that it doesn't warp on me. If I stick it in the drawer now, it might curl and jam up. That's what I'm worried about, because this acetone I used to bond these together, all 3 drawers, well 4 drawers actually, with the driver pulse trigger circuit. So if I don't let it dry evenly so that the air can get to it all the way around, it might curl and warp, and that's what I'm worried about. I don't want that to happen. If you know what I mean, it would be a bit bad if it started warping up inside the drawer and jammed up and then I couldn't get it out. Yeah, so anyway, that's where we are at the moment. I am eager to try it out, but at the same time I want it right, and I want this to be flat, so yeah, I've got to leave it upside down. I've got to leave it upside down so that it, well, for now, and then I might leave it on its side, I don't know yet. Actually, I think it'd be better on its side. It will dry more evenly then. You wouldn't believe that the hassle I had. I even used my frigging hammer. I had to use I used the butt of the hammer to knock my ruler through to get the other ones out, because they were just completely jammed up, absolutely solid. I just couldn't. I thought, what the hell's wrong with them? They won't budge. Then I realised, oh, when I glued that thing back together, it must have bubbled up with the heat, because the plastic, when it's liquid in acetone, you know, this stuff, when it's like liquid, and if you put it on a hot surface, like on the 3D printer bed, as I've seen before, it starts bubbling and it starts to create gas bubbles and it expands like polystyrene. You know, that's how they make polystyrene, I believe, or they use a vacuum to expand it. But anyway, so this started to expand and it bonded the tops of the as I say, the tops of these other coils. As you can see, it bubbled up. You can see the air bubbles in it, can't you? Okay, I don't focus. Why won't it focus? Right, you can see pockets of air bubbles in there. You can, there. Yeah, so that obviously expanded like polystyrene and stuck to the roof of the drawer, which was why I couldn't get it out. Anyway, I'm gonna go now. Hopefully tomorrow, call it 24 hours time, maybe I'll have a test with this new drawer driver module. I suppose I could call it a module, because it's all lump. So I'm using glass fiber tape on top of the coil to make sure that there's no more. If these get too hot, the bits of ferrite that stick out aren't going to bond and stick to the roof of the drawer again. It won't happen this time, because you can't stick anything to this stuff. If you try to stick anything, it's waxy and it just doesn't stick. So I thought, well, this will be perfect, because it will create a boundary layer. Because it's really shiny, it's like silk, it's actually glass, so that's going to have a high melting temperature anyway. That's thermal tape anyway. It keeps the heat, basically, it blocks the heat. Well, I'm not going to be getting it that hot anyway. I am eager to run a test though, to be honest with you. I mean, I could do a quick test, I suppose, but shall I? Yeah, well, alright, like, just give me a minute. I'll just get this phone. Oh, we could do a quick test, I suppose. I don't want to run it too long, because if it gets warm, it could melt. I'm going to stick it in my lamp, if I can get this. Oh, I've got the other camera on here at the moment. I'm going to have to release this other camera, if I can get it off here. Right, get that camera off. Oops, let it hang down there somewhere. Right, let me just stick this in here. Right, let's see. I don't know what it's pointing at. I can't see the damn camera now. I think that's about right. Right. Hope this tape won't come off. It better not. Otherwise my phone will get smashed. I think we're alright. Let me just check this other tape. I think that should hold. I can't see the damn thing. Hang on. Right, I don't know if the camera's. Damn it! What have I done now? I'm going to make it too tight. Right, that's better. Okay. Right, I'll try to hook this up for a quick test. I haven't figured out which way it's wired up yet, so, but it's got to dry out really. I don't want to risk blowing it. I've got my wires all messed up under here. I don't know if these wires have come out of here or what, but right, so I'll stick it in. Timing, I've got to get that on. The timing might be reversed, I don't know yet. I have no idea. Put the timing wires in first. I'm tired of my wrist, is killing me. Oops, bent my wire now. Come on. Right, in. Right, my timing wire's in. I'm going to connect this to the battery because I need to right, we've got lights flashing blue. I don't know if this will trigger the blue light. Oops, wires. Oh shit, look at that, power lead's just broken off. Nothing's working for me right now. I've got to solder this back on. It's one of them days. So I'm going to get a freaking soldering iron back out. I better disconnect that end while I do it. Power. Solder this thing on. While that's warming up, I need to get these wires hooked up. Now I'm not sure, I don't know which way around they're wired up yet, so they might be the wrong way around the first time. I haven't turned this damn thing on, have I? Right. I'm just gonna hopefully I'll get it right first time. Hopefully. If not, it'll go backwards. Probably won't go at all. Right, that's wired up. Now I can solder that wire back on. Right, I'm to unplug my soldering iron now. I need my drill to get started because I'm not doing it with my finger. I'll bloody well get strained. Okay, so is this thing going to work or is it back to front? I'll turn the juice on. timing is probably going to be way off. Well, let's keep my fingers crossed. Right, let's just get it going and see what happens. Oh, I've got the battery on. Do. Battery's just for the driver circuit. Right, let's try again. I've got no blue light. Why is that? Timing coil not connected properly? Ah, we have now. Oh, look at that, it's working. It's a bit slow on the current side, so I've got it wired back to front. It's running though. Let's see if it picks up speed up. It's using too much current, it's 630 milliamps, that's way too high. I'm going to reverse the wiring. I'll turn that off, that's probably what it is. Ah, that's better. I had the boost thing on. I'll wait until it picks up speed and I'll check it. Because it might want rewrite. The wiring might need to be reversed, I don't know yet. I don't know what the RPM is, I'm going to put the RPM meter on. Oh, this has got knocked. Well, we're not running very fast, so let's pick it up speed. But it's, the current is high, so I think I've got it wired backwards. I'm just gonna turn it off because I think I've got the current wrong way around. The wiring, the drive circuit, it's using two. It probably wants to go backwards the other way. So I'm going to swap these wires around. Or the timing could be out. Alright, we'll try again. Current consumption is very low. I think I'm going backwards now. Let's go the other way around, see what happens. Now, I was already going the right way around before. So, yeah, the wiring was correct. It's just the timing wants setting, so I've got to switch the wiring back again. So it was pink on the right. Ah, go on you bugger. I'm only driving this at 22 volts, by the way. It's a MOSFET that's doing the driving. Right, let's try this again. I'll have to, I might have to adjust the timing, that's probably what it is. Let's pull this lot out again. I need to make the timing adjustable because I put blue tack on here so it won't move. Take this blue tack off. Now I've got it packed in there pretty well. Take this blue tack out and I can adjust it, find the best timing for it. Now I can adjust the coil. It moves backwards and forwards like this. You should be able to see that. I'm going to find adjust the correct timing for these new coils. Right, so I'll move them right to the beginning. Is that blue LED on? Yeah. Right, let's try that again. Yep, can hear it firing. Let's get this timing right. That's better at the far end actually now. It's accelerating more faster. Once it picks up speed, I can move the coil and find the best place to put it. We're already at 2,600. I'm going to move it forwards. Oh yeah, it wants to be about the middle somewhere. So I'm actually moving the coil forwards and backwards right now. To find the sweet spot. Hard to tell. Right, it slows down when I bring it forward, so it wants to go further back. I need to just, let's just hopefully get it to stop in that place there. I'll stick the blue tack on temporarily. I need to make adjustments to the trim pots. That's worse. I'm looking at the RPM meter because I'm trying to get it the timing just right on it. It's worse when I bring it there. Well, I'm not getting that much torque actually. Well, what would you expect? It's a new design. So, there's lots of adjustments to make. Right, so it's actually, I am under some load though, but it's actually only doing it. Let's take the load off completely. It's drawing too much current anyway. It's about 500 milliamps. Actually, it's dropped to 360 now. Seems to be okay about there. Stick this blue tack on. Yeah, okay, so I've done a little test. I'll put the load back on again. Yeah, it's slowing down a bit. It has got more torque though. I'll just take the load off again. There's definitely more torque than there was. My phone's going to get cooked, so I'll have to go and end the stream in a minute. Yeah, I'll put the load back on. It doesn't plummet like a stone like it usually does, so that's a good sign. Let's turn this up again. I probably need to change the capacitor on this end. What this capacitor that's on here might want changing to match better, because the capacitor was matched to the other coil. So what I'm going to do is I'm going to take this brown capacitor out. I need to find out. Damn it. I need to find out which value of capacitor is best across the coil now, because so I've taken that one completely out. I have a capacitor across the coil to match it to the circuit, so I'm going to leave that out, put this wire back in and do some, oh was it, yeah, it's pink on this side. We'll try it without one first. Originally I had this, I had a, what was it, a 330? Oh, it's a 220. I had a 220 in originally. So then I went up to this one, which is a, what was it, a 470? So I don't, so it's getting warm. Actually, I don't want to cook these coils, you know what I mean? I mean, let's check them out. Oh, they are getting hot. I messed up my timing now. I think it was about, well, we do the timing anyway. Right, let's try that again. But I'm not going to push my luck with it, because I don't want to warp stuff, you know what I mean? It's still preliminary testing. I need to get the current consumption way down to what it is. Timing's not right, is it? Is this on? It's not firing right now. Ah, there we go. Got a bad wire somewhere. Shit, bloody wires. Ah. Slowing down there. I'm just going to take that load off because it's confusing me. I'll leave that trimmer in the middle. Right, I need to test to see if this 220 helps. No, it doesn't. Let's try this 330. No, current goes down. Current input goes down, but I'm not seeing a gain in speed. Actually, it does gain speed a bit. Take it off. Yeah. That could be my trimming on here as well. Anyway, I'm worried about melting my coils. I don't want to melt them. That's slowing down now. We're not doing very well. We're only doing 3,600 RPM. Maybe my trigger coil wants reversing. That could be it. Let's reverse the trigger coil. Let's turn this around. If I don't get it in quick, I'll have to restart the whole process. Okay, I've reversed the trigger coil. Oops, it's really stalling now. Timing. Well, I've got a connection problem. It's stalled on me. I'll have to start it with this thing again to find out what's going on. Ah, wire connection. Oh, this wire's come out, that's why. Right. It actually seems to like it wants to go backwards. I'm not drawing any current either because this thing is not working. Anyway, I'm going to end the stream because I've got to, as I said, this thing needs to dry out, and my phone's going to die on me anyway if I get a phone out. Oh my god, it's red hot. Phone's red hot. How long have I been streaming for? 48 minutes? Holy crap. Right, so yeah, there's more things to do with the new coil assembly. And I need to take this all out because I want it to dry evenly. Still not dried out yet. So I've got some fiddling to do. I'll probably have to rearrange the magnet poles on it. Something like that. I've probably got my magnets all polarized the wrong way or something silly like that. So yeah, we'll be doing that later. Anyway, thanks for watching.